Hello, this is Mrs. Groves. I'm back to finish up the handout on 9.2b, where we're comparing two-sided tests with confidence intervals for proportions. So if you could have your 9.2b handout ready, your calculator, and we're going to be doing a problem from the book. And if you don't have your book, then I have it open to the page that we're going to be doing. So this is the handout that we're going to continue to work on. And we are going to go to the Check Your Understanding on page 558. And we're going to do this problem right here. Okay. According to the National Institute of Occupational Safety and Health, job stress poses a major threat to the health of workers. In a national survey of restaurants, employees, 75% said that work stress had a negative impact on their personal lives. Managers of a large restaurant chain wondered whether this national result holds for their employees. A random sample of 100 employees find that 68 answered yes when asked, does work stress have a negative impact on your personal life? Is this a good reason to think that the proportion of all employees in the chain who would say yes differs from the national proportion of 0.75? Support your answer with a significance test. Okay, so the big thing to understand here is we are doing a test of hypothesis, and it's going to be a two-tailed because it's asking, does the chain differ from the national proportion? I've already worked out this problem, so I am going to run through it with you and point out some things and show you how to use the calculator. I'm sure you probably could have done it without my help, but here I go. You have to define the population parameter, which is the true proportion of restaurant workers who say work stress has a negative impact. And this is a great template to get you used to everything that you need to do for a test of hypothesis preparing for the AP exam. So you have to tell them what test. This is a one sample Z test for proportions. They didn't give you an alpha, so you're using alpha 0.05. The null hypothesis based on the national survey results is that P, the population parameter P, is equal to 0.75. And does this proportion differ for the chain that's doing the survey from the national average? So this is the alternative hypothesis. Conditions. Okay, we took a random sample of 100 employees. Since we're sampling without replacement, the 10% condition that our sample size has to be less than or equal to 1/10 of all employees in this chain. Since we are doing a test of hypothesis, the normal condition is based on P0, and so we have to check both successes and failures to make sure that they are both greater than 10. All right. So here is the information that you need to do this test. We have a sample of 100. P0, is equal to 0.75. P hat is 0.68. Now I'd like you to pause this video and see if you can finish this problem before I go on. Welcome back. So we want to sketch the for the null hypothesis a two-tailed test. And the two-tailed test, we have P in the middle. Okay, that's 0.75. That's our population parameter. And our P hat, 0.68, is on the lower end of this two-tailed test. So, how are you doing with making sure that you know how to calculate the Z statistic? It's P hat minus the population parameter divided by the standard deviation of the population parameter, which is right there. Right? You fill in the numbers. Okay, so Z P hat is 0.68. P naught is 0.75. We're trying to get a standardized score to see how far this P hat is from the average, the mean. All right, so this is the standard error for the null hypothesis. We calculate it, and we get negative 1.62. The p-value is going to be 2 times the probability that z is less than or equal to negative 1.62. You can use Normalcdf to get this number right here, 0.053. But remember, this is a two-tailed test, so you have to multiply it by 2. So you're getting a very large p-value, 0.106. Now, you can, on the AP exam, make sure you know how to use your calculator to find the Z statistic and the p-value and clearly label them. So this on your calculator, okay, I'm going to trust that you know how to do that on your calculator, and you can go back to my previous video on how to do this. But you're using the one proportion z-test. So z is negative 1.62 when you put it into the calculator, which matches with our hand calculation. And our p-value that we get on the calculator going through one proportion z-test is the same. Now, when you're doing a free response, you do not have to define the p-value, the meaning of the p-value. But you will be asked multiple choice questions, and it might be asked on a free response for you to explain what the p-value is. And basically, the p-value tells you how extreme this p-hat is from your null hypothesis. So the wording goes like this: assuming the true proportion of employees who say work stress has a negative impact on them is 0.75, there is a 0.106 probability of getting a sample proportion of 0.68 or further away purely by chance. Now, on every free response, you will have to state in conclusion, you must compare the p-value to the alpha, give your decision, and then answer it in context. Since the p-value, 0.106, which is very large, is greater than alpha, 0.05, we fail to reject H0. We do not have convincing evidence to say employees at this restaurant differs from the national average for negative impact of work stress. All right, so that's just going through the template for a two-tailed test. And now we're going to go to the next question on this worksheet. Okay. We're going to go through, and now we're going to go to page 561, and we are going to look at computer output so that we can interpret a confidence interval. So now you want to have your books out, go to page 561. Okay. A lot of times on your AP exam, you're going to be given computer output. So here, this check your understanding. The figure below shows Minitab output from a significance test and confidence interval for the restaurant workers in the previous check your understanding, which we just did on page 558. Explain how the confidence interval is consistent with but gives more information than the test. Okay, so this is one sample, 68. Remember, that was the number of successes. N is our sample size. Here is our p-hat. When we did our test of hypothesis, here is our Z statistic, and there was the p-value. So we've already calculated those. The confidence interval, the 95% confidence interval, is right here. It's between 0.58 and 0.77. Okay, so I asked you to interpret the confidence interval. Just as a review from the previous chapter, this, as you can see from the printout, was a 95% confidence interval. And here is the interval. Remember, this is called the confidence level, and this is called the confidence interval. We are 95% confident the true interval from 0.589 to 0.771 captures the true proportion of restaurant workers who say stress has a negative impact on their work. Right? So this, okay, is our confidence interval. Right? Our p-hat was 0.68. We had a 95% confidence level, which corresponds to these tails, which are 0.025 and 0.025. Right? So that's how we have our significance level of 5%, which translates to a confidence interval for 95%. And remember that the confidence interval is only comparable to a two-sample test. You can't compare this with a one-tailed test. Since the confidence interval, 0.59 to 0.77 includes our population parameter 0.75, our decision would be the same. Fail to reject the null hypothesis. Now the question, and I didn't write this down yet, the question that they were truly asking is, what is more information that you get from a confidence interval than you do from a test of hypothesis? Well, from a test of hypothesis, you simply can just say whether you reject or fail to reject. With a confidence interval, all the values between the lower bound and the upper bound are possible population parameters. So any of these numbers in here are plausible values. So it gives a lot more information, okay, than does a test of hypothesis. Now, just want to make sure that you see the differences between a two-tail test of hypothesis versus a confidence interval. So we're going to go to your book on page 563, and we're going to do numbers 50 and 52. And as we're going through those two problems, okay, we're going to compare the what the differences are when you do a test of hypothesis and a confidence interval. So what I'd like you to do right now is to pause this video and read these two problems. And in case you don't have your book with you, here is problem 50. First-year college students, they want to be rich. And then the next question that we're going to compare it to is number 52, which is doing a confidence interval. So I would like you to try to complete this yourselves and then come back and check your answers. All right. All right. So on the left-hand side, we're going to do a test of hypothesis, and on the right-hand side, we're going to do a confidence interval. And hopefully this way you can see the differences that take place between doing a test of hypothesis and a confidence interval. In both cases, you must define the population parameter. And here, P is the true proportion of first-year college students who believe it's important to be financially well off. Okay. So, for a test of hypothesis, we're going to do a one-sample Z test for proportions. For a confidence interval, we're going to do a one-sample Z interval for proportions. Since they didn't state the alpha, we're going to have alpha 0.05, which corresponds to a confidence level of 95%, which is 1 minus alpha. The null hypothesis is P is equal to 0.73, and the alternative hypothesis that P is different than or not equal to 0.73. The random condition is the same for the test of hypothesis and confidence interval. It was stated that there was a random sample. The independence condition is the same for both. Our sample is 200, and that is going to be obviously less than 1/10 of all first-year college students. Where it is different is that the normal condition. For test of hypothesis, we're going to find successes and failures based on the null hypothesis p0, 0.73. And for the confidence interval, we're going to base it on p hat, which is 0.66. Okay, so I'd like you to pause the video now and see if you can complete this problem on your own. While I go get my calculator. I'm back. So this is the null hypothesis. For the null hypothesis, we draw this. It's a two-tailed test. All right, our p-values are on each end. Our population parameter, 0.73, is in the middle. And our evidence is our p-hat, which is 0.66, which is below 0.73. So our p-hat is over here, and we need to find that p-value. Compared to a confidence interval for p-hat, where you notice here the population parameter is in the middle. Here, the p-hat, or the sample statistic, is in the middle. Okay, so p-hat's equal to 0.66. We're going to find a lower bound, an upper bound, and we're going to take it from there. These are the calculations that you need to be familiar with. Okay. So when you're doing a test of hypothesis, you're looking to find how far, with a z-score, your p-hat is from your null hypothesis, and you should have gotten negative 2.23. The p-value is going to be z is less than or equal to that negative 2.23, but you need to multiply it by 2. So let's just make sure that you know how to do this with your calculator. Okay, so stat. Oh, they're good. We go to tests. We are going to a 1 proportion z-test, because we're doing the test of hypothesis first. Our null hypothesis is 0.73. X is the number of successes, or the number of people that believe that they want to be rich, out of our sample of 200. This is a 2 sample. If it was a left tail, I'd hit the less than. If it was a right tail, I'd hit the greater than. But it is a 2 tail. I am going to hit calculate, and you get, this is your alternative hypothesis. Here is your Z test statistic, which is the same as we just calculated. That P is the p-value. Here is your p hat, and n is equal to 200. Right. Another thing that you can do with the calculator is you can go back stat, tests, and you can have the calculator show you a picture of the normal graph. So we're going to go back to one proportion z-test. We already filled everything in. And this time we're going to say draw. And there you go. You can see that z gives you the z value. Here is the p-value. Half of the p-value is in the right tail and half of the p-value is in the left tail. Right? It's very important on the AP exam that you're comfortable with the calculator. Okay? You want to be comfortable with the calculator and you want to be comfortable with your green sheet. So now, this is the calculation for our confidence interval. That is p hat. That is the z critical value. 95% is always 1.96. All right? You can always think of it this way. Since p hat is 0.66 and that's the middle of this graph, then that's what the standard error is going to be. So we get 0.66. The margin of error is 0.066. And we take this, add this, and we get the upper bound, which is 0.726. And then we get the lower bound by taking 0.66 minus this value. We get 0.594. Right? So you'll notice that I labeled those on this graph. Right? This is 0.726. And our p-value is 0.73. So it is to the right of the upper bound. So you should ask yourself, what does that tell me whether I'm going to reject or fail to reject? And we'll get to that in a minute. But let's make sure that you're comfortable with the calculator. So you're going to go stat. You're going to go to tests. You're going to now do a confidence interval. So that is a one proportion z interval. Okay. So our so again, and what's nice, because we did the test of hypothesis, when we go to do the confidence interval to compare it to, it populates it with the correct numbers for you. So all we have to do here is say calculate, and we get basically the same answer here as you did here. Just want to reiterate a couple of other calculator commands because I think it's pretty easy to see it here. When I wanted to find the p-value, here to find that p-value, I need to use Normalcdf. So Normalcdf is here under with distribution, so second distribution, Normalcdf. Okay, you could put in a big number like that, negative 9999 to negative 2.23. This is a standard score. So I hit paste, enter. That's one tail. I have to multiply it by 2 to get the p-value for the two tail. Okay. To make sure that you understand how to find the z critical value, right? That's where you use inverse norm. So you're going to go second strip, inverse norm, and the area comes from the left. Right? So the area comes from the left. So this is 0.95. I'm left with 0.05. Half of it is here, half of it is there. So that means that this area is 0.025. 0.025. Paste. And there you go. That is the critical Z value. Just want to make sure that you're comfortable with those calculator commands. Okay, conclusions. All right. Since the p-value, 0.026, is small and less than alpha 0.05, we reject the null hypothesis. We have convincing evidence that students at this college are thinking being well off differs from the national average. I'm sure you could have worded that much better than I did, but I think you got the gist. So that is test of hypothesis. Okay. Now the confidence interval, I told you, gives us more information. We are 95% confident the true proportion for this population parameter, for these college students wanting to be well off, is between basically 59% and 73%. Now if we look here, so this is going to give me the area here. From here to here, that's going to be my fail to reject. And if it's above the upper bound or below the lower bound, that is my rejection region. Since 0.73 is above, since the population parameter 0.73 falls outside the confidence interval, we reject the null hypothesis. So that concludes section 9.2b. Have a great evening, and I'll be preparing another video for you to watch soon.